All right, guys, so this week we're looking at specifically exponential functions, and we're going to be looking at their properties, different parts of the graphs, intercept, things like that. So there's 4 or 5 different ones, and we'll just go right into it. There's no particular order you have to do these in, but this is just the order I typically do it in. So first we have what we're calling our initial value. Some people call this a starting value. It is also always the y-intercept of the graph. Well, this is always your A every single time. Okay. All right. Next will be knowing whether your function is an exponential growth or exponential decay. Okay. Now your exponential growth for your growth and decay, you're always going to look at your B. So your B is growth or decay. Now, if it's growth, your B value will be greater than 1. If it's decay, your B will be between 0 and 1. So it's kind of like, our vertical stretch and compression with exponential with quadratic functions. But here it's your B, and it tells us whether it's growth or decay. Okay. Now the next part is kind of a new vocabulary word. It's called asymptote. And all that means is that it is a line that you approach, or the graph approaches, but never touches. Okay. So that's 1, 2, 3. And now there's either 4 or 5. The last part is going to be domain and range. That just depends if you count those as 1 or 2. Your domain for exponential functions is always all real numbers. And your range is always going to be y, and then greater than or less than a number. Okay. Either less than a number or greater than a number. Okay. All right. So, one more thing I want to mention about growth. Your exponential growth, for the most part, your graph looks like that. It goes up. For decay, goes down. Okay. But those values of B make those graphs look like that. Okay. All right. So let's look at example 1. Okay, good. It's all on the screen now. So you look here. The first thing I would always do is identify what your A and B are. So here A is 4 and your B is 2, because that's going to give you a lot of these parts. So you're here, your initial value, which is also your y-intercept, if we graphed it, is your A, which is 4. Now growth or decay, we don't have the graph, so we look at our B. B is 2, so that's growth. All right, so now we look at domain and range. Domain is all real numbers. And your range for this one is going to be y is greater than 0. And then we'll explain that a little bit more on the graph. Now here, your asymptote is y equals 0. And we'll explain that more on the graph too. A lot of the ones you have will probably be y equals 0. Okay. but we'll let you be able to actually see that on the graph for example 2. All right, so here example 2, we're going to start off A and B. A, notice there's nothing multiplied in front here, but you're multiplying, and any number that you multiply is a factor, so there's a 1 being multiplied here in front. Okay, so that means A is a 1, and then B is 3. Okay, so that means your initial value is your A, which is 1. That's also your y-intercept, so we're going to go ahead and graph that. Okay, and now we're going to look at growth or decay. Well, B is 3, so this is growth, and it has a growth factor of 3. I think I forgot to put that on example 1 here. Yeah, here your growth, this is your 2, your B is your growth factor, just meaning you're multiplying by 2 every time. Here, example 2, your growth factor is 3. You're multiplying by 3 every time. Okay. Next will be our domain and range. It's a lot easier to see that on the graph. So let's finish graphing this. We'll fill out a table. We'll see -2, -1, 0, 1, and 2 for x. And then y, we're going to plug those in. -2 in for x, so that's 3 to the -2 power, then 3 to the -1, 3 to the 0, 3 to the power of 1, and 3 squared. All these, that gives us 1 over 3 squared, which is 9, 1/9. This will give us 1/3. This, anything to the 0 power is 1, so that gives us a 1. That's 3, and that's 9. So now -2 is 1/9. That's really, really hard to put down there, but we'll just put something there. Then 1/3. Now notice here, that's 1/9. If we went to -3, that would be 1 over 27. So this is just going to get a larger and larger fraction. I'm sorry, a smaller and smaller fraction. Larger and larger number in your denominator, which means this is going to keep getting closer and closer and closer to 0. But the only way it can be 0 is if your numerator is 0, and this will never be 0. Okay, so it'll never actually reach 0. So then we have the 0.13, then 2, 9. And there's our graph. Okay. And now we look at domain and range. Domain for all exponential functions is always all real numbers. Your range, this looks like it's going to hit 0. It gets as close as it can, but never touches it. So any number above 0, because our graph here has an arrow, goes up for infinity. So any number above 0 would work. So our range is y is greater than 0. Okay. All right. Now let's look at one last part. Example 3. Okay. We want to write our equation. A is our starting point, our y-intercept, which is 2. So this is y equals 2 times something else. Okay. Now we know that this is decay. See, this goes down. So this is decay. It's exponential decay. So that means B is going to be between 0 and 1. It's going to be a fraction. So if you look right here, okay, We know that our y value is 1 right there. So we know that 1 equals, we already have a 2 times something to the first power, right? So times something over here. Well, 2 times what is 1? Well, 1's half of 2, so times 1/2. So that means this is going to be 1/2 x. And our domain is still all real numbers. Our range, even though it's going in the opposite direction, it's decay now, it's still getting closer and closer to 0, and it goes up forever. So y is greater than 0. And our asymptote is that point that it reaches, that it approaches but never actually touches. So that's 0. So the line y equals 0, which, once again, I forgot something else. I didn't do that for the example 2, which it's at 0. So for number 2, our asymptote is y equals 0, because right there, the x-axis, which is where y is 0, the graph gets closer and closer and closer to, but will never actually touch. Okay? And then here we found the equation, which you won't have to do that much this week, but it was good to have the practice of looking at the graph and finding the parts from the graph. But that's it. All right, so y'all have a good day. Good luck on this. Have any problems? Go to the office hours, contact your teacher, and y'all have a good week. Bye-bye.